Hey everyone, happy Monday. So today we're going to be starting still same section 6.2, and we're going to be talking about inverses and determinants. So we've learned matrix addition, matrix subtraction, and matrix multiplication. We've learned matrices are not commutative, meaning matrix A times B is not necessarily the same as B times A, also on your quiz last week. Now, you might be asking, is there such a thing as matrix division? So, not really, no. Not the way you guys know. So you guys are used to, like, I don't know, if I have 3x equals 6, to solve for x, we divide by 3. So we can't do that with matrices, but we have, because you can't actually divide the way you guys know and love, or maybe you don't love it, but whatever, there is something very similar to it. So before we start that, we're going to talk about the identity matrix. The identity matrix is denoted with a capital I. Usually we put a little number next to it depending on like what the dimensions are. So is it a 2 by 2 or a 3 by 3 matrix? And that being said, it has to be square. So the identity matrix is always a square matrix with ones on the diagonal and zeros everywhere else. So if I had a 2 by 2 identity matrix, that's going to look like 1, 0, 0, 1. A 3 by 3 identity matrix would be 1, 0, 0, 0, 1, 0, 0, 0, 1. And it keeps continuing in this pattern. So 1, 0, 0, I'm going to do dot, dot, dots. We'll be going down. Dot, dot, dots. And it just follows this pattern. Okay. So the thing about the identity matrix is by having all these ones in the diagonal, when multiplied, by a square matrix, and square is important, you get that matrix. So an identity matrix times a matrix A that is square, you're going to be left with A. And then interesting enough, this also happens when you multiply that square matrix A by the identity matrix. So matrix A times the identity matrix will also give you matrix A. So that's really cool and interesting because remember, direction matters. We did this last week. B times A is not the same as A times B, always. Sometimes it is, sometimes it isn't. So remember, direction matters. So it's unique that this works. So let's go back in time. to Algebra 1. So in regular math, I'll even write that down. In regular math, A times 1 or 1 times A gives you A. We also know that 1 over A times A equals 1. And remember, this 1 over A is the inverse of A. And this is also the same thing as dividing. Now, remember, this is the same, like this is just regular algebra math. This is not with matrices. So the question is there an analogy? Is there a way to do this for matrices? And obviously the answer is yes. So if I were to have matrix A, the question is there something I can multiply? Is there an inverse of A that I can multiply by so that I'm left with the equivalent of 1? Now, matrices are, there isn't just like a number 1, but we have the identity matrix. So if we multiply an inverse times the original matrix, we will get the identity matrix, and that should also work the opposite way. So A times A inverse will give us the identity matrix. So yes, there is such a matrix, the identity matrix, or sorry, the inverse matrices. But before we get to that, let's learn how to verify. So for verifying, if we want to verify two matrices are inverses, we're going to do exactly what we did above. So essentially, if they're inverses, we should be left with the identity matrix going both ways. So you must, this is really important, or you will not get full credit, you must multiply both to verify. And this is partially because matrices aren't commutative, so we want to make sure it does work both ways. And then it's also because you guys, this is your first time doing matrices, and sometimes you mess up, so you might accidentally mess up and think it works, but it actually doesn't. So if we verify both ways, that's kind of your safety net. So we're just going to do one example. Determine if A and B are matrices, or sorry, are inverses. So matrix A, we're just going to do a 2 by 2, keep it simple. -2, 4, -4, 6. And matrix B, 3/2, -1, +1, -1/2. So in order to verify that these are inverses of each other, or maybe they're not, we need to do matrix A times matrix B and see if we get the identity matrix, and matrix B times matrix A. So I have a feeling you guys could do this on your own, so if you want, you could pause the video now and try to do it. So A times B, remember we're going to do -2 times 4, sorry, -2, 4 times 3/2, 1, and add them together. So -2 times 3/2 is -3, plus 4 times 1, which is 4. And make sure you show one line of work like this at the very least. -2 times -1 is +2. 4 times -1/2 is -2. Then bottom one, so -4, 6, and the 3/2, 1. So -4 times 3/2 is -6, and 6 times 1 is 6. -4 times -1 is 4, and 6 times -1/2 is -3. And then we'll simplify this, and -3 plus 4 is 1. 2 minus 2 is 0. 0, 1. So we did get the identity matrix there. Now we need to do BA. Because this order isn't an easier way, I'm going to rewrite it real quick. So I got 3 halves, -1, 1, -1 half, times matrix A, which is -2, 4, -4, 6. And now let's multiply, and hopefully we get the identity matrix. So 3 halves times -2, -3, -1 times -4, +4. 3 halves times 4, 6. -1 times 6, -6. -1 times -2, -1 half times -4. And then 4 times 1, and -1 half times 6. And when we simplify all this, we do get the identity matrix. So you need to show your work at the very least these 2 lines. Although I really recommend this one because these aren't in the order, you'll probably mess up. And then we need to make a conclusion, so we're verifying, and we can conclude since A times B times matrix B times A equals the identity matrix, and it's a 2 by 2, so you could throw that 2 in there. These are inverses. Cool, so we are all set. Now, the question is, how do we calculate just an inverse? So we learned how to verify, right? Inverse, if we multiply them together, we get the identity matrix. So how can we just find an inverse? So I'm just going to do one example. We might have to go into 2 videos, sorry. And then tomorrow we can practice this some more. So how to calculate inverses. So calculating with a 2 by 2 matrix is pretty straightforward, and that's what we're going to be focusing on. 3 by 3 is a little bit harder, and 4 by 4 is going to take you a while, and a 5 by 5 you definitely want a calculator. But we're just going to do 2 by 2. So if you have matrix A, and let's say that that equals A, B, C, D. What you're going to do to find the inverse is you're going to take the determinant, which is 1 over AD minus BC, so the diagonals, AD minus BC. And we're going to multiply that by, now it's not matrix A, it's a new version, so it's D, negative B, negative C, A. So the first diagonal are going to switch places, the other diagonal is just going to become the opposite sign. So there's a reason for all of this, but for now we're just going to memorize the steps. There are definitely videos out there that help you. So the determinant, this is the determinant, is noted as, kind of looks like the absolute value of A. It's got those bars around the capital letter, is equal to AD minus BA, like we said before. This is just a scalar quantity that we're multiplying by a matrix. So another way to note this whole thing is saying still the determinant and then multiplying it by D, negative B, negative C, A. Now, really important, the determinant cannot equal 0. Which should make sense because it's 1 over the determinant. So if the determinant is 0, there's no inverse.